Welcome to the Occupational Safety Leadership Podcast, episode number 295 with Bryan Haywood. And in today's episode, I'm going to do everything I can to not talk. This is something that I really don't have that much experience about. So Bryan is going to go ahead and talk about complex lockout-tagout procedures. For me, I've done really easy lockout-tagout procedures. You can stand in one spot, see all of the energy that you have to go back and isolate the hazards. But Bryan will talk about it on a very large scale. So, Bryan, let's just get right into it then.
All right, thank you, David. So, as you mentioned, your experience was in what we call traditional lockout. And this is really what 1910-147 was written for. And, it's a manufacturing facility of some type. It's got, machines that operators run. Those machines have two or three, four, five forms of energy, and someone like you or I will go out and we'll write the lockout procedure that OSHA requires, the machine specific energy isolation procedure for that piece of equipment. And so we go out, we get the electrical, we take a picture of the disconnect with the number on it, and we put it in there and says, go throw the disconnect, come back, hit the start button. We do it for compressed air, we do it for gravity, we do it for hydraulics, any of the energy sources. And
Mhm.
you literally write the procedure, laminate it, and stick it on the machine. So the operator, all they have to be is trained to follow that procedure. It's already given to them. But when I'm standing there doing a lockout tagout audit or, an investigation or something along the lines involving LOTO, I always look up to the, compressed air system that runs around the plant and have all these drops. And I'm like, because, they'll tell you they have a procedure for every maintenance task they do, right? Because they're thinking of the machines on ground level. And every one of those machines has a LOTO procedure. They're being audited every year. But I grabbed the maintenance guy and I said, so you gotta change that valve out, that 3-inch valve up there on that compressed air line that's operating at 140 psi. Show me the procedure for that. And of course, the group just falls silent because you can't have a procedure for every single thing in the plant because you're going to go from 150 procedures to 4,000 procedures. So
Mhm.
when PSM came along in 1992, and then the confined space standard came along a couple years later, like 94, 95, OSHA sort of realized that 1910-147 was not written for those what OSHA has come to call complex processes. And so, there's the traditional approach to LOTO, which you have your written procedure with pictures and everything. And then you get into these complex. So if you read 1910-147, the rules still apply to the complex process. You still have to have a specific, well, you have to have an energy isolation control plan, it's what we call it in the chemical industry, um, based on the scope of work. So you're going to change that 3-inch valve out up in the air compressor line, the compressed air line.
Mhm.
So, you're doing a line break basically. And, just to give caveats to the ANSI group that does the Z244 standard for LOTO, a number of years ago, they actually wrote a chapter, I think it's chapter 8, where they talk about locking out piping systems, which was their entry into complex systems. And they even use the phrase line break and so forth. So I give them a lot of credit because it was badly needed because people like me and you go into these plants doing these audits and we're like, you got to have a written procedure for that work. You're doing maintenance and servicing. You got to have a procedure. Well, how do you expect us to write a procedure for everything? Well, back in the day, they were called just-in-time procedures.
Mhm.
So that operator or that engineer or that maintenance tech has to be trained at a level that most safety people are trained at in LOTO. And what I mean by that is they have to know how to identify a hazardous energy source. So we have to quantify and define what is a hazardous energy source, right? Then they have to be able to figure out what's the magnitude of that energy. How are they going to isolate that energy? What is the acceptable means of isolation? Is it a valve? Is it a blind? Is it a disconnect and misalignment, dropping a spool piece? How are you going to isolate that energy? And then how are you going to verify that that isolation method actually took that energy source to a zero energy state? And we have a little table that we put in our programs where it's a like a worksheet. You know, you have the type of energy in the first column, the next column is the magnitude, the next column is the isolation means, and the next column is means to verify zero energy. And we always get it where somebody will put lockout in the isolation, and no, the lockout is securing the isolation device. You have to put what device did you hang your lock on? That's the isolation device. So you're training these folks, it's like you and I were talking earlier about, you go to some of these plants and you're training an authorized person who's going to be following those prescribed procedures that are, written and posted on the machine. That training could be anywhere from 30 to 45 minutes, right? You just got to make sure they know how to operate the isolation device and actually put the lockout device on that isolation device. That's usually the big hurdle you have to get over. When you're training these folks on complex and they have to figure this out on their own, you're looking at a 4 hour training class, because you're literally training these operators, engineers, and technicians to be the safety person, to have the knowledge level of a safety person in lockout in those kind of complex environments.
Mhm.
Okay. So, you know, um, you know, I go back to Z 244 where they literally talk about, if you're doing single valve isolation or you have positive means of isolation, what are these, do you get credit? Like if you're doing, like I just did a line break class for a client, and I'm like, if you've got single valve isolation on both sides of the break, you will wear your PPE throughout the whole work time. Right? If it takes you 4 hours to change that pump out, you are in full PPE that you wore when you've made the first break because you only have single valve. Valves leak, valves fail. No way in the world would we put someone in that situation, although a lot of people do, but not in my world.
Mhm.
So
Right.
if you had double block and bleed on both sides of the break, then we basically say the permit issuer could allow the workers after the initial break, and the isolation is holding, you can lessen the PPE. You can get out of your full chemical suit. You can get out of your respirator, because you have what we call positive means of isolation on both sides. But the person who's writing this energy isolation control procedure has to understand the value of doing a double block and bleed or a blank or a blind, and that what a positive isolation means is versus a single valve. Um, so it's what we've come to call complex lockout. So that air example, when they build these compressed air systems and these loops around the plant, there is zero thought about maintenance, right? It's just an air
Yep,
system.
exactly.
Well, air is a hazardous form of energy, right? If it's
Mhm.
100, 20, 140 psi in that pipe, and that's a 3 inch pipe, and there's a quarter mile of that pipe, that's a lot of energy in that
Yep.
pipe. All right.
Mhm.
So for you to change that valve out, that's a line break, right? A lot of plants will define line break as even if it's just pressure like compressed air, if it's over 30 psi, then you got to have a line break because it's a hazardous form of energy. In most people, that 30 psi comes from the 1910, I think it's 42 or 142 for the cleaning, compressed air, using compressed air for cleaning. It has to be below 30.
Mhm.
But anyway, you ask the people in the group, you say, well, how would you lock it? How would you lock the system out? Well, 9 out of 10 times you have to actually shut the entire compressor system down because guess what? There's no isolation valves on either side of that valve. That's the valve coming off the compressor that's leaking, and you don't have a valve between it and the compressor, or you don't have a valve downstream. So the only way you're going to be able to get that pipe around that 3 inch valve you have to change to a zero energy state, shut off the compressors, lock them out, bleed the entire system, just blow it down, just open up the vents and blow it down, open the blow down valve or the vent valve and lock it open, right? Go to
Mhm.
your gauge on your system somewhere near the where you're going to be opening it and verify that it's at zero energy. And you have to document that. Air is your hazardous form of energy. It's 120 is the 120 psig is your magnitude. Your isolation method is lockout of the air compressor. And the way you verify zero energy, well, then you got to have another line that says you're bleeding it by this opening this bleed valve and locking it open, and then you're verifying that you achieve zero energy on a pressure gauge somewhere on the system. And you have to fill that little form out to be able to get the permit to open that system up. And that would be an example of a complex process. Another example that a lot of people fall short on is documenting your energy isolation control for reclassifying a permit required confined space, or for the matter of just doing a permitted entry, whether you're doing a C7 reclassification or you're doing a permitted entry, which is sections D through K of 1910-146. You have to isolate that space. That space they're calling into has to be basically suspended in animation and nothing's connected to it. No way any of the process energies can get into the space. So you only have those three methods that we talked about in some of our confined space discussions: double block and bleed, disconnect and misalignment, or blinding or blanking. Those are the only three acceptable methods that you can use, especially if you're going to be reclassifying the space, right?
Hmm.
Um, so most people don't have procedures for their 750 confined spaces they have labeled out in the plant. All right. So that would be part of your line break or equipment opening. A lot of people don't realize that when you're taking the manway off of a confined space that's been in service for 5 years, that is an equipment opening. So you need a line break just to be able to take the manway cover off. Before you can get the line break procedure, you got to have the tank at a zero energy state, which means all the piping going to it is isolated in one of those three methods. And then somebody could go out there and say, okay, we're ready to take the manway cover off, right? That's a line break. Once the cover's off, the line break permit's canceled, and now you're going to issue a permit required confined space entry permit, or you're going to reclassify the space. And both of those are going to require you to take that documentation that you had on the line break permit, transfer it over to your permit required confined space entry procedure, because the entrance and especially the entry supervisor has to walk down that LOTO again. It may have been someone different that wrote the line break or equipment opening permit. Now you're going to have a supervisor from the unit come out and issue the confined space entry permit. So he or she's going to take that same energy isolation control plan that was literally written for the line break, right? And they're
Hmm.
going to make a copy of it, or they're going to just take it from the line break permit and put it with the confined space entry permit. And they're going to walk it down to verify that you had all these proper isolations. Now, the reason why this is significant to understand is the person who isolated the vessel to issue the line break permit did not necessarily have to have double block and bleed, disconnect, misalignment, or blinding or blanking for the line break. But for the vessel entry, you've got to verify all your pipes, ducts, tubing, everything that can convey a hazardous form of energy to that space is isolated in one of those three forms.
Hmm.
That's the only three methods of isolation you can do. So you're going to have that worksheet that's going to identify the nitrogen line. It's double block and bled or blanked off. You're going to have the caustic line. You're going to have the water line. You're going to have the steam lines. You're going to have the chemical lines. You're going to lock out the agitator. You're going to lock out the auger at the bottom of the reactor. All these things have to be documented. And then how are you going to isolate them? Well, no one has a pre-written procedure for that, right? So that's a complex process. So when you're getting ready to do the entry, you're going to go through this exercise. And usually, it's not done within a silo or a vacuum. It's multiple people involved. Sometimes some of these vessels can take 2, 3 shifts to lock out. But everybody is following the energy isolation control plan that was written for this complex LOTO. And there's so many opportunities, David, to make a mistake.
Hmm.
And, somebody, we had an incident at one of my employers where I think we may have mentioned this in one of our confined space, where We had it on video. We had two operators on the top of this, 100,000 gallon reactor. This thing's massive, right? I mean, won't fit under bridges. This thing's massive to go down the road. And they're on this thing, and you see them locking stuff out and everything. And they're using a piping and instrumentation diagram, P&ID, which is the roadmap for your chemical process.
Hmm.
And the P&ID the vessel was modified about 2 years earlier for a quality reason. And what was added was a nitrogen pipe. And it was only a 1/4 inch pipe, and it was just flowing nitrogen in there to try to scavenge some of the oxygen out to allow the product to last longer before we transferred it over to the storage tank.
Hmm.
And that 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 quality change did not go through an MOC, a management of change. Therefore, the P&ID was not updated. Therefore, the operators were literally ticking off, they were Xing out each line that they had isolated. And we literally watched them for an hour on video, sped up video, working all around that nitrogen pipe. That nitrogen pipe is labeled, it's green, it's got a green label with white letters, got a directional flow arrow saying nitrogen going in. But they were so blinded by just following the P&ID that they locked out everything on that vessel except the nitrogen. Had the entry supervisor not done the proper atmospheric monitoring, the pre-entry monitoring, we would have killed 4 people, right?
Hmm.
Because the
Right.
oxygen in the space was like 3%, right? It was lethal. So when you're doing these complex lockouts, and you're using a document like a piping and instrumentation diagram, this is why these documents have to be maintained 100% accurate, because that's what we're using. If I went out and said, David, we got to enter reactor number one, first thing you would do would be go grab this P&ID for reactor number one, and you would start marking up all the nozzles on the vessel and say how you're going to put a blind here, we're going to double block and bleed this, we're going to roll this spool piece out on this one, and you're filling that form out as you're coming up with this plan, and then you're giving it to the operators to go out and walk it down, verify it, and then to actually execute the isolation. And that's all done the day before or 2 days before. And it requires, what we always did was double verification. You would get somebody, not necessarily out of the safety group, but you would get somebody to do a double verification, someone that's not attached to the work, that doesn't have any biases or any blinders on. And they
Right.
would go out and just walk the entire vessel. You got to remember, these vessels go through 2 or 3 floors. So you start at the top and you go to the second floor and you walk it and you do the ground floor. I mean, it could take, hour, two, maybe 5 hours to walk down these 75 to 150 isolation points. Um, so that is an example of complex, reclassifying a space, doing a vessel entry permit, required confined space entry permit, plant air systems, plant water systems, a lot of utility steam, steam headers and boilers. These are, complex processes where we just can't walk out and write a procedure and put it on the machine. And here's a good example. I had a client years ago that was a global food client, big international company, and they had this packaging machine that was sterilization machine,
Hmm.
and this machine had like 42 lockout points, and they had a placard on the sides of this thing that looked like size of a door, and it had every energy source and the magnitude and how to isolate it. And I thought, I walked out there during shift, and there was this young lady had the guards off, and she was cleaning something. A milk, a jug came down, a carton came down, and it didn't line up, and it sprayed the product everywhere. And she had to go in and clean it to maintain the sterilization and so forth. So I walk up, and she's got the guard sitting on the ground, and I'm like, "You have this thing locked out?" And she's like, "Oh no, I don't have to lock this out. I'm pretty no interlocks, no anything." Right. So I go over to the sheet, and that's when I found this long sheet that basically had all these energy sources. And so I go back to the supervisor and I'm like, well, that's a complex piece of equipment. It's a confined space. If you climbed inside it, it would clearly be a permit required confined space, not labeled as such. They had a procedure, and this is what I call check the box exercise. They literally went through and said, here's all the energy types, here's where you would isolate them. Nothing about verifying zero energy, but they had them listed. So my question was, is does she have to lock out all 42 to do that task? And they're like, oh no, she should have only locked out number one, number seven, number 14, and number 25. And I'm like, did you train her what to lock out? Oh no, I guess we should. So when you have a machine like that and you write a procedure, you get the worker one step further by identifying all the types of energy, their magnitude, and how to isolate them. You've gone one step further, but when I'm doing task X, I don't have to lock out all 42. I only
Right,
have to lock
right,
out these four. So I need a procedure for how to do this task. And in that procedure, it will tell me to refer to the LOTO placard, and I only 1, 7, 14, 21, and 28 apply, right? So I know those are the four that I have to lock out. So that's another way you can manage complex processes. But just sticking it up on the machine and saying here are the 42 chances to kill you, you take your chances and which one you want to lock out. You
right.
know, it makes it much more user friendly for the operator. And the company was not real happy. They went through the exercise and identified them all, but they weren't utilizing that information. That machine was not being locked out except at the end of the shift. And then they weren't even locking all 42 out because the department couldn't even come up with 42 locks
Wow.
uh, across the whole board. And I'm like, you should probably have, and there was three of these machines. So we went in and we basically updated the list of 42, told them how to verify zero energy for each one, and then gave them a lockbox, the old traditional red lockbox, like a
Uh-huh.
ammo box that everybody uses, attached it to the side of the machine, and inside it were 42 individual locks. And all the locks were individually keyed because you may be locking out, uh, you know, 1, 3, and 9, and I'm locking out 1, 4, 8, and 16. We can't have the same keys to each other's locks, so they all had to be
Right.
individually lock keyed. And again, people don't understand this concept of exclusive energy with two people working on this massive machine. You need to have exclusive control of your isolation control points, and I need to have exclusive control of mine. Therefore, the locks have to be keyed individually. Um, so, that's examples of what a complex process is. And, using an energy isolation control worksheet that basically sets this is the type of energy, this is the magnitude of each of those energy types, this is how I'm going to isolate it, and this is how I'm going to verify zero energy. And you fill that out and you get that approved. That's the same procedure that the operator running the machine is looking at. He just has pictures and fancier stuff. We just have a worksheet.
Right.
Um, and that's that's how we do lockout in a chemical process for line break, vessel entry. Anytime you're opening a system up that's non-routine, you've got to have an energy isolation control plan before you can even get your LEO permit, your line and equipment opening permit. And it's just a way of life. But you go into some of these plants that are so used to the traditional, and then you go to the boiler, to the boiler, and you look at all the steam and the hot condensate return. They don't have any procedures for that, and no one is trained on how to develop a procedure for that. And it's a major challenge. In most places where we see the really bad accidents, it was a complex process. You have more accidents on the traditional, but they're typically not as severe. Where you have the catastrophic failures, or when you're in these complex units and people just did not understand lockout energy isolation control for that complex process.
Right.
Example I give you, and I'll shut up and let you ask a question. Um, Compressed air. I mean, I think I've maybe seen 10 procedures in my lifetime of auditing as a consultant over the last 20 plus years of auditing Lotto. You got an airdrop coming to the machine. There's a quarter turn ball valve on the machine. The hose clamps in there. and the procedure will tell them to close the valve, right? And I'm like, okay, well, that's a quarter turn ball valve. What else do you do? Well, it's closed. We close it and lock it. Well, it's not at zero energy. There's still trapped air between that valve and the machine. Oh, well, we hit the start button to verify. And I'm like, the start button is only verifying the electricals, the right electricals locked out. You're not verifying anything by hitting the start button because the electrical has nothing to do with the air. The air is a different energy source. So, in 2026, everybody should be using what's called dump valves, which is you turn that valve to the off position, a piston drops out of the bottom. You're by closing the valve, you're isolating the valve from the air source, and then that piston drops out, and you bleed all the air from the machine through that piston. And then there's a gauge on it that literally will go from 120 or whatever the feed pressure is to zero. So right there in that one, what we call a dump valve, you get isolation, you get bleeding off, and you get verification of zero energy. But if you don't have that, and you're just closing a quarter turn ball valve, that's what's called stored energy. And it may not be a lot of volume of air, but it may be enough volume of air at the required pressure to make that machine do one little cycle while your finger's in there, and now your finger's chopped off.
Right.
So, when you're doing LOTO, traditional or complex, that means to verify zero energy, just to get it to a zero energy state is usually more difficult than the lockout. You were talking
Oh
about
yeah.
draining sulfuric acid out of a pipe. That's usually more difficult than closing the valves and putting locks on them. Now you got to start the work. Now you got to get that sulfuric acid between those two closed valves drained into a proper container that's labeled with the right hose, with the right PPE. The container probably needs to be sitting in a secondary containment in case you underestimated the volume and you overflow your toad or your 55-gallon drum. All of this is where the real work begins. And that should all be part of the line break procedure, because when you open that drain valve, you are opening a process, and you should be suited up for that level of hazard. So again, you're doing a line break process, a permit as part of your energy isolation work to change that valve out in that sulfuric acid.
Right, right, right. So the one thing that we also did is that we knew that if something had to be down, let's look at what else we can fix too. Because
Oh
if
yeah,
something
yeah,
if something's broken, there's probably something else that maybe you haven't discovered, or it not that it was broken, but that there's an issue, and you can just kind of push it to the next time that things are down then. So,
yeah.
so
Good planning will go a long ways in a good maintenance program.
yeah, yeah, yeah. I really like that dump valve. I have not run across that. Now my stuff's really small and very very easy, so I have not run across that dump valve. So I'm gonna go back see if I can find that for my stuff then.
Yeah, you just do a Google search. I mean, that's the slang name. I can't think of what the official name is.
Right, right, right.
I mean, and they're all different. There's probably a hundred different manufacturers today of them. I just did a new plant in Florida over the last 2 years, and I convinced the engineering manager to install them on all their equipment coming off the main line, coming off the air header, and it saves them so much time, because if you don't have that dump valve, you still got to put a quarter turn bleed on there somewhere to be able to get the air out of the hose or the pipe that's from the valve to the machine. And that's what's called stored energy, and you have to get rid of it, and it's very difficult. I've had a few where they have the water filter, the filters and the water drains,
Mhm.
the knockout pots to keep moisture from going up in the machine. And you can open that little drain. It's just like a little bitty plastic little valve, and you can turn it, and it'll drain all the liquid and water out, and it'll also bleed the air out. But when I do my bleeds, I lock my bleeds open. That was the way I was taught. That is how you
Right,
verify that, or you ensure that if the valve leaks by, you can't reaccumulate that energy. And with stored energy, that has to be part of your LOTO program. So we always lock the drain valve open. With these dump valves, it's just a single valve. You turn it off or close it, And when you close it, it isolates the air, drops the piston, and now that piston is always in the open position. So even if the valve bleeds by, it's not going to reaccumulate in the system. It's just going to go out into the room.
Right,
Uh,
right, right.
and they used to be hundreds of dollars. Now I think you can buy them for probably $100 or less, depending on the size and the pressure rating. And they make your life on. If you have compressed air in your facility hooked up to your machines, it will make a huge difference in efficiency of locking out the equipment every day.
Oh yeah, yeah, yeah. Luckily for our stuff, it's really meant to run. So when something has to have some maintenance to it, typically it's going to be like predictive stuff because we don't want to run it until it breaks, of course, and then you're really scrambling, trying to hurry up and fix it. So we do
Mhm.
more of lockout on the like predictive side, just to really keep things up and running.
Yeah, so a lot of the plants, I don't do that much in food industry anymore because I gave up ammonia refrigeration. But um, in the food plants, they're cleaning, every evening, and it's usually contractors, which that's a whole nother
Oh
topic that we
yeah,
could talk about. And so we would go in, do these audits, these process safety audits, and of course they'd always want us to do the contractor part of it, and we would always look at LOTO because you can almost guarantee you that there's six contractors working on this machine. There's only one lock on the lockbox, and
yep,
there should be six, right? And the person who put the lock on the lockbox doesn't even have the key in their pocket. They gave it to their supervisor. So, I mean, we find some crazy things when you start getting into these complex where you got 24 lockouts on a piece of equipment or isolation points, and there's 24 keys in the lockbox, and you got 15 people working on it. That's a lot of locks.
right.
And typically we don't find contractors, in the cover of darkness, even beginning to lock out. And I'll say this now that I got 1 minute left. Contractor, contractor in a manufacturing facility, chemical or making widgets, should never be allowed to place a lockout lock directly on an energy isolation device. One, they are not authorized employees in our lockout program. Two, they're probably using a different colored lock that we've never trained our people to recognize as lockout. So we have to identify our lockout locks by color, shape, or size. Almost everybody does color. And we train our people that red, blue, and orange are our lockout colors. Contractor comes in with a pink lock, starts hanging it. No one can recognize that lock. That they're not trained to recognize that. So even though the 147 has the contractor section, it basically says the contractor has to tell the host employer how their lockout works, and the host employer tells the contractor. It doesn't work that way across 3 shifts, across 1,000 people, and across 40 other contractors work. Everybody on site has to be trained. So what we do is contractors will only put their locks, doesn't matter what color, with a tag identifying their name and their company name